Hi friends! Welcome to our very first flipped class video. So Unit 0 was all about, rehashing, flipping back to pre-algebra to make sure that we're set up really well for Algebra 1. So now that we're actually starting Algebra 1 in earnest, maybe it makes sense to also flip our classroom. I don't know. So we'll see, but don't worry. You will still be taking notes, you will still be asking questions, you'll still be solving problems, and most importantly, you'll still be listening to me make really bad jokes that probably don't really quite land. But now with the added power of pausing and rewinding and slowing down and speeding up and anything else that you need that will hopefully give you a little bit more agency and hopefully comfort, right, in your learning. Or at the very least, it'll give you the opportunity to listen to me make my bad jokes all over again. But hey, enough about that. Let's do some algebra. So we closed out our previous unit by talking about, how do we handle quote-unquote simple equations, right? These equations that really only need one or two moves to get us to where we want to go. But from here on out, the equations that we're going to want to make sense of are a little bit more complex. But the fundamental tools that we established back in Unit 0 are still just as powerful and just as reliable, no matter how simple or complex the equations we're working with are. So let's see how we can use them. So remember, math is all about asking good questions. So as a bit of a reminder, a good question maybe to ask yourself is, well, if I'm solving equations, what is it exactly that I'm trying to do? You should know this really well, but take 10 seconds, pause. What does it mean? Like, what am I trying to do? And what does it mean? What am I trying to do? And what does it mean given an equation? Go, pause. What do you think? Okay. Given an equation, we should know really well that my goal almost always is to solve it. And in order to solve an equation, right, I might think about what I'm going to do, but what it means to solve an equation, you should know really well. To solve an equation, the idea is that I am trying to find the value, or sometimes the values, of the variable that make, or if I've got multiple, right, makes, that make or makes the equation true. Our big word here is true. If you remember nothing else, remember that word true. I want a true mathematical statement, not just any, but a true one. Cool. So that's what I want to do. I want to solve it. The next question then that you're probably asking is, well, how do I do it? That's my goal. What's my strategy? How do I achieve it? Well, you tell me. What do I need to do in order to solve an equation? What do I want? What do you think? 5, 4, 3, 2, 1. Okay. To solve an equation, the strategy that I use is, of course, to apply my inverse operations. And I'm using those inverse operations with a particular goal in mind. Specifically, I want to use my inverse operations to get my variable by itself. Our fancy mathematical word for that is, of course, to isolate. So I want to get my variable by itself by undoing all of the things that are connected to it. Not variables. Variable. I want to isolate my variable. Very nice. So we're going to amp it up a little bit. We've talked about simple equations. Let's talk about some multi-step equations with a few more steps between us and the isolated variables we want. So the title of our lesson today, Unit 1.1, our first class of Unit 1, let's talk about some multi-step equations. Part 1. Okay. For an example of a quote-unquote multi-step equation, let's flip down here, kind of bridging the gap. Not too many steps, but still more than 2. I've got 4 parentheses 7 minus x equals 8. So before you think about solving this, I want you to pause, game plan for a second. My goal is to get this value x by itself. What's the series of steps that I'm going to take and in what order to achieve that? Pause, reflect. What do you think? Go. Okay, so I've got 4 parentheses 7 minus x equals 8. Well, if I'm thinking reverse order of operations, right, my strategy is opposite of PEMDAS because solving is the opposite of simplifying. I'd probably want to get rid of any addition subtraction I can see first. So my original temptation might be, well, let's look at this 7. However, there's something around the 7 that's kind of going to keep me from dealing with it yet. And that is, of course, our parentheses. If I'm doing SADMEP, right, my reverse PEMDAS, then those parentheses need to happen last. So I should actually get rid of the stuff attached to the parentheses first. So there are two ways to do that. One way that you can do that, well, this 4, I could, of course, distribute. This is a prime case for the distributive property. So let's say that I distribute. Well, if I do distributive property, I have 4. Distribute it to 7, of course, I'm using multiplication. So it's going to be 28, or 4 times 7. And then our 4 minus x, or 4 times minus x, would become negative 4x equals 8. And from here, I'm in familiar territory. So reverse PEMDAS, in this case, should get rid of the 28 first. That's a little bit easier to get rid of than the negative 4, but I could if I wanted to. So I'll do my minus 28 first. I've got negative 4x equals 8 minus 28, which is negative 20. And then divide both sides by negative 4 to get x by itself. So here, these friends will undo each other, just as these friends undid each other up above. X is going to equal negative 20 divided by negative 4, which is positive 5. So x equals 5. But there's another way. If you're thinking strategically, right? Like, what's another move that I could have made to begin with? So I'll rewrite over here our 4 parentheses 7 minus x equals 8. Well, remember that the 4 is connected by multiplication. So another move that I could have done, well, could I have started by just dividing both sides by 4? I needed to do it eventually. Why not do it now? It turns out, yeah, I can absolutely do that. Let's get rid of this here. So 4 divided by 4, that becomes just 1. And then I'm left with my 7 minus x. And here, 8 over 4, that's going to reduce to 2. And then from here, I've got 7 minus x. So I want to get rid of the 7 here. So I've got, in this case, our 7 and our negative 7 undoing each other. 2 minus 7 is negative 5. And then the temptation would be, well, I got rid of the 7, so I've just got the x left. However, remember that you've got this invisible, or in fact here, very visible negative sign. That negative doesn't go away here when I get rid of the 7. It's attached to the x, not the 7. So that negative x needs to come down. And then my last move between me and freedom. Well, I've got negative x equals negative 5. So if negative x is negative 5 and I want positive x, well, positive x should be positive 5. So notice here that both of these answers I got in slightly different ways. In this case, maybe you had a preference for one move over the other. It doesn't really matter. But I don't want you to get bogged down in this idea that there's only one way to do it. Either of these choices will get me to the place that I want to be. Maybe one is slightly more efficient than another, but it doesn't really matter. You will usually see me choose this method because it's slightly more efficient and I often end up working with slightly smaller numbers. But that doesn't make it better. It's just a different way to get to the same answer, whichever you prefer. Alrighty, let's do a couple more. So let's take this friend. I've got 2 parentheses n minus 6 minus 1 equals 31. So again, take 10 seconds, just look at this. Pause and game plan. What's the series of steps that I want to take in what order to get my variable n by itself? Go ahead, pause. What do you think? Okay, so I've got 2 parentheses n minus 6 minus 1 equals 31. For me, if I'm looking at this, the easiest thing for me to get rid of here, again, reverse PEMDAS, this negative 1 is looking real nice. So I'm going to take this negative 1, let's undo it with a positive 1. So I'll start by adding 1 to both sides. In this case here, these friends will undo each other. I've got 2 parentheses n minus 6 equals 31 plus 1, which is 32. And then from here, same idea as before. If I wanted to, I could distribute, but in this case, it actually saves me a little bit of work to just divide both sides by 2. But if you wanted to, you could absolutely distribute. There's nothing wrong with that, still a totally fine choice. I'm gonna choose to divide both sides by 2 here. Here our 2's will undo each other. I'm left with n minus 6. And on the right side, I have 32 divided by 2. Well, 32 divided by 2 is 16. And from here, I'm happy I know what to do. I want to get my n by itself. The only thing in the way is that negative 6. Let's use a positive 6 to get rid of it. These friends undo each other, and n is going to be 16 plus 6, which I believe is 22. Okay, so we've got a couple problems under our belt. Let's see if you can do some on your own. Try these two. 3p plus 5 over negative 2 equals 9, and 17 equals 8 minus 3 parentheses b minus 10. So again, my goal is to solve for p or solve for b. What steps am I going to take to get those variables by themselves? So set like a 2-minute timer, 3-minute timer. Give yourself some time, see how far you get. Don't need to get all the way through, but give yourself a fighting chance. Let's see if we can solve each of these equations. Go ahead. Alrighty, so either you've just done a little bit of problem solving, or you sat there in awkward silence for 5 seconds. New for me, right? I'm usually talking, but hey, listen, we're all capable of growth. So let's do it. I've got 3p plus 5 over negative 2 equals 9. Well, my opening move here, again, my temptation would be, oh, look, plus 5, inverse operations. However, there's something in the way of that plus 5 that's going to keep me from doing anything with it until it's gone. That is, of course, our fraction bar. Remember that fraction bars are grouping symbols, and I can't do anything with the numerator until that denominator is gone. So my actual opening move here, if I want to make my life easy, I want to get rid of my fraction. Well, fraction bar negative 2 really means division by negative 2. Let's multiply both sides by negative 2 to get rid of it. So our negative 2 and our negative 2, these guys are going to go away. I'm left with my nice 3p plus 5 in my numerator. And then on the right side, 9 times negative 2, well, that's negative 18. And then from here, I'm home free. So again, reverse order of operations. The plus 5 is easier here to get rid of than the divide by 3. So I'm going to do plus 5 and minus 5. These undo each other. 3p is going to equal negative 18 minus 5, or negative 18 plus negative 5, if that helps. That's negative 23. And then from here, divide both sides by 3. In this case, 3 and 3. They undo each other. So our value p is going to be negative 23 over 3. So the question that I want to ask myself now is, well, can I simplify this further? I could write it as a mixed number, but I don't really like mixed numbers. Let's leave it as an improper fraction. 23 and 3, they don't have any common factors. Or Gucci, so p equals negative 23 over 3. Cool. On the right, let's do 17 equals 8 minus 3 parentheses b minus 10. Well, here, again, nice opening move. I see an 8 that's all by itself. I can do something with that. We'll subtract 8 from both sides. 17 minus 8 is going to become 9. And then here, that's negative 3 times b minus 10 left over on the right. Again, same idea. I could distribute if I want to, but it might be slightly more efficient here and give me some smaller numbers to work with if I divide by that negative 3 instead of multiplying it out, because I'm going to need to divide by the negative 3 anyway to get the b by itself. Let's do it now. So negative 3 over negative 3. These friends undo each other. I've got b minus 10 on the right and 9 divided by negative 3 on the left, which becomes negative 3. Last thing between me and b by itself. Let's add 10 to both sides. So the value of b that we need is going to be negative 3 plus 10, which is, of course, 3,056. Cool. So you can write check if you want to make sure, if you don't believe me, that 7 equals b is going to make our equation true. Plug it back in, figure it out for yourself. But all of our tools should work in the same way, right? In math, our guiding principle is often, if it ain't broke, don't fix it. Well, it ain't broke yet, so we're not going to fix it. Cool. Let's see a slightly different version of a problem like this. We'll do a couple more problems, and then we'll be done. So take negative 12 equals 9t minus 6t plus 15. My goal, again, is to get t by itself. But again, ask yourself a question. What's different here? What is slightly different about this equation from any one that we've seen before? Take 5 seconds, pause. What do you think? What's different here? Okay, well, if you're like me, my goal is to isolate, which means I want to get just the variable, in this case t by itself. which means on one side of the equation, I want just one t. But if I look at this, I don't see one copy of t, I see two. So my next question should be, well, if I want to make this look like what I want it to look like, what choice could I make to turn 9t minus 6t into something with just one t? Well, those are like terms, which means I can combine them. So let's do 9t minus 6t. Well, I have 9 of them. I take 6 away. I'm left with 3 t's in total. And then I have plus 15. And now I'm in familiar territory. I know what to do. Reverse order of operations. Easiest thing to get rid of is the plus 15. So I've got negative 12 minus 15, which is negative 27. That equals 3t. And now I need to undo multiplication by 3. Let's use division by 3. On the right, these guys undo each other. I'm left with t. And on the left, negative 27 divided by 3 is, of course, negative 9. So negative 9 equals t should be our final answer. That's our solution. If we plug it back in, we should get a true mathematical statement. Cool. Let's do another. So same idea here. I've got some parentheses in this case that I want to get rid of, but I also have 2 copies of y, and I want to get down to just 1. So let's do it. Take a second. Game plan. What strategy might you use here to get this equation to a point where you can put those y's together? Go ahead. What do you think? Alrighty. Well, lots of different ways that we can do this. For me, if I see something like this, I have y's that I want to put together, but the problem is those parentheses. I can't combine them just yet. So I want a way to get rid of those parentheses. Well, I have a lovely little property that allows me to take anything next to a parentheses and, I don't know, maybe distribute it to the stuff inside. Let's use the distributive property. So on the left, I'll take my 5. Let's distribute that to 3 and negative y. And on the right, I've got this 2 that's right next to it. But remember here, am I just distributing the 2? Well, no. I've got this negative sign in front. These are attached to each other. So I've got to distribute the full negative 2 to both of these terms. So here on the left, I've got 5 times parentheses 3 minus y. Well, 5 times 3 is 15. And 5 times negative y is negative 5y. Then I distribute my negative 2. Negative 2 times 3 is negative 6. And negative 2 times negative y, well, negative times negative is positive. And then 2y. Carry down my equals 18. And then from here, probably a good next move. Well, do I have any like terms on the left side I can combine? Heck yeah. Well, let's start with the negative 5y and the 2y. So negative 5y plus 2y. I have negative 5y's. I add 2. So I've got negative 3 y's in total. But I've also got this 15 and this negative 6. Those can also be put together. Well, 15 minus 6, that's 9. So I've got negative 3y plus 9 equals 18. And from here, once again, I know what to do. I'm in familiar territory. Reverse order of operations. Let's start with our addition. We'll undo it with subtraction. So I'll subtract 9 from both sides. Cancel out my 9's here. Negative 3y is going to be equal to 18 minus 9, which is just positive 9. And then I have negative 3y equals 9. Well, the thing standing between me and y by itself is this negative 3. It's connected by multiplication. We'll undo it with division. Y equals 9 divided by negative 3, which is just negative 3. Very nice. So I've got a lot of different tools in my arsenal here. I just want to think strategically about how I can use them. Let's see 2 more. Like before, I'll give you a little bit of time to work on these on your own. So we've got 11j, negative 11j, minus 6 plus 3j equals negative 30. And then 6a minus 2 parentheses a minus 4 all over 3 equals 8. Same idea. Give yourself a little bit of time, 2 minutes, 3 minutes. See how far you get. And then we'll come back, we'll work through these together and see if we can find the values of j and a that will make each of the equations true. All right, set your timer. Pause the video. Let's do it. Go, 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 go. Okay. We're almost there. Let's do it. I've got some like terms on the left side that I want to combine. Immediately I see an 11j and a 3j. Let's put them together. I've got negative 11 plus 3, so I have negative 8j's in total. Carry down my minus 6, carry down my equal sign, negative 30, and now I know what to do. So I've again got some reverse order of operations I can take care of. Add 6 to both sides to get rid of our negative 6. Negative 8j is going to be equal to negative 24. And then here, j is connected to negative 8 by multiplication. Undo it with division. These friends undo each other. And then this friend is equal to negative 24 divided by negative 8. Negative divided by negative is positive. 24 divided by 8 is 3. So j should be 3. And then on the right, so I've got here another example of an invisible grouping symbol. Remember, my fraction bar serves as a grouping symbol. Can't do anything with the numerator until the denominator is gone. So I've got division by 3 that I need to get rid of. Let's undo it with multiplication by 3. So here, 3 on the right side times 8 will give us 24. On the left side, we get rid of our denominator, so we just carry our numerator down. And here again, I want to put these a's together, but I can't yet because of the parentheses. One way to do that is to get rid of them by distributing. So I'll take my 6a, and then I've got this negative 2. Again, my negative travels with the 2 there. I've got to distribute that. So my negative 2 times a is negative 2a. Negative 2 times negative 4 is positive 8. And then here I'm at 24. So from here, you might look at this and say, well, look, 6, negative 2, 8, 24. Is there another move that I could make here? And there is. We'll talk about it tomorrow. But for now, we'll do it the way that we've done. But I want you in the back of your mind to think, is there another choice, thinking strategically, that I could make here to make my life a little bit easier? Well, if you're not thinking that way, which is totally fine, you might notice, well, 6a minus 2a, I can do something with that. Let's turn that into 4a. 6 minus 2 is 4. Carry down my plus 8 equals 24. And then from here, I've got plus 8. Well, let's subtract 8. Reverse order of operations. These friends undo each other. 4a equals 24 minus 8, which is 16. And then here, divide both sides by 4 to get a by itself. Last thing in the way, a is going to be 16 divided by 4, which is 73. Alrighty, so j equals 3 in the first one. A equals 4 in the second one. If you don't believe me, plug it back in, use your substitution property, check and make sure that these do in fact give us true statements. Or you can just believe me. But listen, do what you want to do. Okay, congratulations, my friends. You have made it through your first video class of Unit 1. We'll talk more about this tomorrow. Come prepared with questions. Make sure those notes are looking real notey. And we'll chat. Thank you. Take care, be good. Have a lovely